Okay, welcome back to section 7-8 on our algebra journal. We're going to be looking at factoring. So yeah, let's go. Let's get started. Here we go with our 7.8. If you are playing along at home, then you know that you should be over here on page 239. All right, so it starts off with some factoring stuff. I don't know exactly what we're supposed to factor here. I do know that if this was x plus 1, as that says right there, and then another x plus 1, like it says over in the second monomial, and then this is a minus 2. Okay, well, that one is easier for me. That's just kind of how my mind works. Maybe yours doesn't, but I think the first thing that you should do here is foil things out. So let me do some foiling in blue. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And then 1 times 1 is 1. So those two monomials come together. Those two binomials come together as this, it's going to be a trinomial. And then we still have that minus 2 left over at the back over there. Okay, next I think you should take these guys and simplify that. So you get an x squared plus 2x plus 1, and we still got that minus 2 floating out there in the back. And then we're going to distribute that negative 2. So you got negative 2 times x squared, that's negative 2x squared. Negative 2 times 2x, that's negative 4x. And then negative 2 times positive 1, that's negative 2. So that's everything kind of that's everything kind of expanded is what they would say. Everything has been foiled and distributed, and what you are left with is a polynomial in this case. So at the end of all of these, you should get polynomials. That's what you're looking at there. Okay, next one, matching standard and factored forms. This exercise here, I think, first of all, let's take that one, let's put it out over here. We got x cubed plus x squared, and we say, is there a, well, they both have an x, right? And what's the smallest power of x? Well, that's x squared. And if you undistribute, remember, undistribute means you're going to take those x's and you're going to subtract the powers. So you got x cubed and x squared, you're going to undistribute. 3 minus 2 is 1, so that's x to the first power. Then you got x squared. 2 minus 2 is 1. And if you ever get a power of 1, that's just the constant 1. So just to rewrite that, I know that we don't usually write the first power. So that's just x squared x plus 1. That's what we call undistributing in some parts of the world. And notice that if you foiled this out, if you went backwards and foiled back into the polynomial, you would get x cubed plus x squared, which is kind of what you started with. So you kind of did it right. Let's do another one. Let's take a look at letter C. Letter C, we've got x cubed plus x squared minus 2x. And let's take a minute and let's get out that if there's a monomial that divides into all of these. And the first thing I always notice is they all have an x. And the smallest power of x is x to the first power. So I'm going to undistribute that x to the first power. And as I do that, I'm just going to take all the constants, leave them alone, all the, what do we call those? We call those coefficients. Leave the coefficients alone and subtract the powers. So x cubed, no coefficient, but 3 minus 1 is 2, so x squared. X squared, no coefficient, so we'll leave that alone. And then 2 minus 1 is the first power, minus, now the coefficient, again, you're going to leave that alone, 2. And then you got the x, 1 and 1. 1 minus 1 is 0. So that is a 1. Anything to the 0 power is equal to 1. Alternatively, you don't even have to write that 1 because there is that coefficient of 2 holding our place. So back at it, now I can kind of rewrite that as x parenthesis x squared plus x minus 2. And I can say, well, that's a trinomial, quadratic trinomial. So I think that requires factoring with the x method. So luckily for me, this is the easy x method. All I need to do is put the negative 2 on the top, the positive 1 at the bottom, and let's think two numbers that multiply to make negative 2, or just 2 really. Well, there's really only 1 times 2. And if I want to get a positive 1, that's going to be 2 minus 1 equals 1 positive. So this is a negative 1 and a 2, or if you like, 2 and then negative 1. So factoring this back over here, you get x minus 1, x plus 2. Notice that monomial, binomial, binomial, nothing else is factorable. So we are done with that. So that's how we factor. Oh, we're supposed to match up. Let me show you a quick, if you ever get in this situation where you're matching up, let's take letter F, for example. This is a case where you can kind of work backwards. I feel like I'm teaching you how to cheat here, but this isn't cheating. They want you to match, so work backwards, okay? So you've got x plus 2, x minus 2. Now I recognize that as a sum and difference. If you didn't recognize that as the sum and difference, then you can just FOIL it, but FOIL it like that. But we spent a lot of time yesterday with special products, so I recognize that as a sum and difference. So I'm just going to write that. That's x squared minus 4. That's the main reason why we learn that sum and difference formula. It makes life a whole lot easier. And then now I'm going to distribute that x. So we've got x cubed minus 4x. Let's see, x cubed minus 4x matches with this guy right here, g. So this f matches with g. Okay, so that's how you would play that game. Just factor and match. Sometimes it'll be easier to factor, sometimes it'll be easier for you just to expand. All right, next. How can you factor a polynomial completely? We touched on this. The first thing to do is to factor any common monomials, which is that process of undistributing. Lastly, if there's a remaining trinomial, you're going to have to use the x method. If it can use the x method, either the easy one, if a equals 1, or the hard one if a is not equal to 1. You can pause the video right here if you need to copy it down. I'm going to move on. We're going to use your answer to question 3 to factor each one completely. Let's take one of these. I choose U, letter C. X cubed plus 6x squared plus 9x. Let's see, all three of those terms have an x on it, so I'm going to just put an x. The greatest common factor of 1, 6, and 9 is 1. Only a 1 will divide into all three of those. I'm going to put that silent 1 there. Okay, so really x is the only common monomial I have. Let's factor that out. Third power minus the first power, that's the second power, plus coefficient stays. Second power minus the first power, that's just x to the first power, plus 9. x to the first power minus x to the first power. That's x to the 0 power, which we know is 1. I'm going to be smarter this time and just put a 9 and not a 9 times 1. All right, going to look here, and I'm going to pretend that I don't see that that is a square. And I'm going to say, okay, I got to use the x method here. I get to use xez method. You got the 9 on top, the 6 on the bottom. These are both positive. Let's see, what numbers multiply to make 9? That's 1 times 9. That doesn't get me a 6. That's 3 times 3, and that does get me a 6. 3 plus 3 equals 6. So we'll put a 3 here and a 3 here. And since this is the easy method, I'm done factoring. That's x plus 3, and then another x plus 3, or x parenthesis x plus 3 squared. Okay, that's factoring completely. Okay, here's a new one. Factor by grouping. This is when we group the binomials with common factors. Sometimes we're going to group trinomials with common factors, and then we're going to undistribute from there. After we undistribute, there's actually another undistributing step. We'll take a look at that when we get there, but we're undistributing an entire binomial instead of undistributing a monomial. So the next one is undistribute with the factor completely. You undistribute, you use the x method until every factor is a monomial or a binomial. Basically, unfactorable units. Factor by grouping, we're going to try this here. This is a guideline for factoring completely. You can read this. It's a lot of what we said. Factor, greatest common monomial factor. Look for a difference of squares. If not a difference of squares or a perfect square, you factor ax squared plus bx plus c. And if that doesn't, and once you're done with that, you're going to factor a polynomial with, polynomial with 4 terms by grouping. And we'll do that later. Okay, we're going to look at that. That's if you have 4 terms, factor by grouping. It's an interesting concept. Honestly, I don't see it that often in math. Maybe I shouldn't say that, but this feels kind of weird sometimes. So let's take a look at this. We're going to factor by grouping, and the first group I'm going to look at is this one right here. Okay, so if I take a look at this, I got a b cubed and a 4b squared. They both, this has a 1 coefficient, this has a 4 coefficient. Both 1 and 4 are relatively prime, which means that their greatest common factor is 1. So I don't have to worry about the coefficients. But the smallest power here is b squared. So b squared, b cubed, 3 minus 2 is 1, 2 minus 2 is 0. And then I'm going to take a look at this one over here, b and plus 4. So their greatest common factor is, they don't have the coefficient in front of the b is a 1. Like we said before, 1 and 4 are relatively prime. And they don't both have a b. So to make this look like I've factored, I'm going to factor out the 1. Okay, now that I've factored out the 1, I take a look at what I have left, and I notice that both of these terms have a b plus 4. So I'm going to take that b plus 4 and I'm going to factor out that b plus 4. And this is weird because we're factoring out a binomial instead of a monomial. So we've factored out that binomial, b plus 4. And what's left over? Well, there's that b squared. And what's left over here is a plus 1. Then I take a look and I see a square there and I say, can I factor b squared plus 1? And actually you can't factor that one. That one is unfactorable. So this is our answer, b minus 4, b squared plus 1. You can write that the other way around if you like, b squared plus 1, and then b minus 4. All right, let's move on. Let's do one more of these. factor by grouping. And I want to show you what happens if you have a negative sign here, okay? So the first thing I'd like to do is rewrite so that this is plus negative 30a minus 5. That's the very first thing I want to do. I want to get that plus minus 30a, because as I group them now, I always want to group it with a plus sign in between. So now that I have that plus sign in between, this is the plus sign I'm talking about right here. I'll always want to have a plus sign in between those two binomials. Now that I have a plus sign there, I'm going to factor out from this first binomial. Let's see, 12 and 2, is there a number? What's the biggest number that goes into 12 and 2? And you know the answer is 2. How about this, a cubed and a squared? The smallest power of a in that case is a squared. So 12 divided by 2 is 6. A cubed, factor out an a squared, so that's a to the first power. 2 divided by 2 is 1. I'm going to not write the 1. A squared divided by a squared, that is a 1, or a to the 0 power. Since I don't have a coefficient anymore, I better put that 1 there. Okay, plus, now I'm going to take a look at this second one, and I'm going to say, well, if there's a minus in front here, I am obliged to factor out a negative. A negative something, I don't know what. It might be just a negative 1, but whatever that greatest common factor is, I'm going to factor that out. So 30 and 5, is there a number that goes into 30 and 5? And what is the biggest number that goes into 30 and 5? The answer here is 5. Okay. So plus negative 5 parenthesis, let's see, 30, negative 30 divided by negative 5 is 6, and I still have that a. Negative 5 divided by negative 5 is a positive 1. If you're cheating a little bit, you notice that these two binomials are always going to be the same. So a little bit of premonition, I guess, is the correct word here. Okay, last step here. We're going to factor out our greatest common factor. This time, this happens to be a binomial. Both of these terms have a 6a plus 1. So I'm going to write 6a plus 1. Then I'm going to say, well, what do I have left? What I have left is a 2a squared plus negative 5. Okay. If you prefer, and I don't see why you wouldn't prefer it, that'll be 6a plus 1, and then a 2a squared minus 5 instead. That looks a whole lot neater. All right. And then there's a couple more of those. You can try these if you like. I'm going to pause it right now, and if you want to try 8, go ahead and try 8, and then in 3 seconds, pause it, and then I will show you the answer. Okay, here's our answer over here. This way, I got to get used to which direction to point. You got the 7. Notice that I went and I put that plus sign in between here. Factored out the 3h squared because both 21 and 18 are divisible by 3. Next, we went ahead and we have an h squared as the smallest factor in these first two terms. Factor that out, you got a 7h plus 6 plus negative 35, negative 30. I know that a negative 5 goes into both of them, so negative 5, 7h plus 6. Go ahead and factor out the 7h plus 6, and you get 3h squared minus 5. Now, taking a look at that 3h squared minus 5 over there, I might be able to factor that because that is a difference of 2 squares, kind of. I know I see that square there, so I'm tempted to see, can I factor that? But 3h squared is not a perfect square. Negative 5 is not a perfect square, so I don't think there's anything I can do here. I am finished with number 8. Okay, let's move on, and I think we're almost finished here. We've got a few that say to factor these completely, so let's factor them completely. The first one that catches my eye is number 10. Let's factor that completely. I'm going to write it here, 100x x to the fourth minus 25x squared. Take a look at those two numbers. Is there a number that goes into both 100 and 25? What is the biggest number? Yeah, it's 25. How about the x's? Both of these terms have an x, and the smallest power is x squared. Okay, now that I've done that, 100 divided by 25 is 4. X squared divided by x to the fourth divided by x squared is x squared. 25 divided by 25 is a 1. I'm not going to write the 1 just yet. X squared divided by x squared is 1. Now I'm going to write the 1. And I say, oh, ho, 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 look at that. This is a difference of squares. So 25x squared. Square root of 4x squared is 2x. Square root of 1 is 1. So here is my fully factored polynomial. Okay, let's try question 14 next. Pause it right here for you, or I'll write it first and then I'll pause it. Let's change pen colors here. So you've got a 12x squared minus 20x minus 48. Pause it right here and you can work on it. I'll come back with the answer. 3, 2, 1. As I'm working, I notice that this is one of those X difficult ones, and I just decided to start calling these extreme. So we're going to start calling those extreme. That's really funny. So catch up, you can pause it here and then keep working. Oh, I didn't see you there. I'm just about to finish here. We've got 4 multiplied by this top one, which is x minus 3, multiplied by this bottom one, which is 3x plus 4. All right, that's our extreme problem. And we're going to go ahead and do one more of these. This is solve the equation. I think we're running a little bit long here, but let's go ahead and solve the equation. We'll do this one first, number 18. We've got 5y squared minus 5y minus 30. Take a minute here. I'm going to pause it for you to factor that. I notice that all of those monomials are divided by, or divisible by 5. Hint, hint. Okay, on pause, look at that. We've got, after we factor out that 5, we can factor that pretty easily. I didn't show the x method, but that's all I used was the x method. And then from here to the next line, I remember that we did a long time where we could solve this really easily. So if this is y minus 3, the solution is y equals 3. If this is y plus 2, the solution is y minus 2. We're going to do one more, and then you are off to do your big ideas. 22, I'm going to write that over here. I'm going to write that over here. X cubed plus 3x squared equals 16x plus 48. And the first thing I'm going to do is subtract everything over. We'll do that together. So we got x cubed plus 3x squared minus 16x minus 48 equals 16x plus 48 minus 16x minus 48. Notice that we are subtracting here and here. Okay. And always a good idea when you're factoring things in higher orders to make one side equal to 0. So what do we got? We got x cubed plus 3x squared minus 16x minus 48 equals 0. Just a tip for you before I pause it. 3 times 16 equals 48. Yeah, I would have had a hard time with that one too. So take a minute here, solve it. I'm going to pause it now, and we'll come back with the solution. Okay, so we're back, and you notice that we've factored this by factoring by grouping. And I notice here that we've got an x squared minus 16, and that's factorable, right? X squared is a perfect square, 16 is a perfect square. So pause it again and factor that. 3, 2, 1. And we're back. That's the best, how many minutes for that? 25 minutes of factoring you're going to do today. Over here we can see we got x plus 3, x minus 4, x plus 4. We do the easy method. If x plus 3 equals 0, then x equals negative 3. If x plus minus 4 equals 0, then x equals positive 4. And if x plus 4 is equal to 0, then x equals negative 4. So that's all of the solutions to this one. That was a difficult one, and hopefully you stuck with it. Try your big ideas, and I'll see you next time when I wear a different headband or the same headband. I don't know. See you guys later.